Hello, my name is Brian, and I'm here to do some hacking on Tiger Beetle. Tiger Beetle is a high-performance financial database, and it is written in Zig. It has clients for... Sorry, I'm messing with my monitoring. It has clients for Java, Python, Go, etc., but no Rust client. So this project that we've been doing on stream for about 2 months now is to create a Rust client for Tiger Beetle. All the Tiger Beetle clients are bindings to a library called TB client written in Zig that exposes a C API. So this is a project about FFI and kind of exposing a C API as an idiomatic Rust API. I think it's got a lot of, it's a very bite-sized project, but a lot of nice rusty subjects. It's an async API, and there's a lot of unsafe code here, and quite a number of unsafe considerations that we run into over the course of this stream. So right now we're kind of in the process of, we made a lot of progress recently, and we're in the process of preparing an initial PR for the Rust client. This PR is not going to be production ready, but it should present a complete API, and it should basically work if people want to try to use it. I expect there'll be performance work afterward. We haven't been focused on performance. I've been focused on making the API Rust idiomatic. And there's going to be testing work and performance work for sure after we get the initial PR done, and maybe we'll get some feedback and iterate. Also, we might add some additional like niceties, conveniences on top of the core API, which is fairly raw, also fairly simple though. But regardless, we've been making really good progress, and I have a to-do list of a few more items to tackle before we do a PR. And so today we're going to look through that to-do list and try to pick a few of those off. All right, give me 1 second here, y'all. I'm fine. Let's keep going and find the code. Let's see. Where am I? Okay, so I've already rebased onto upstream and cleaned up my history a little bit. Every time we sit down and start, I do a little bit of housekeeping, but I'm not doing that on stream today, though I am going to rebuild the Tiger Beetle client library that we bind to. Let's see if I have the history here. That's it. So I haven't hooked up, I haven't wired the Zig Tiger Beetle build system into the build system cargo for the Rust client. And that's one of the things we need to do on the PR. And I don't think I have a to-do for that. So every time I need to, work on this, I need to make sure I have an up-to-date static library for the Tiger Beetle client library. Here's my list of what we've accomplished so far here on the right. Make sure I'm showing you my screen. I always forget to show my screen. I'm kind of keeping a list of what we've accomplished for the eventual upload to YouTube, which we're close to. Eventually have a YouTube playlist of all this stuff. And here's our to-do list. Let me make sure I've got the most recent buffer. Some bit fields, some work on the destructor, test harness, API docs. All right, there's more here. We need to wire up build system. That'll be a very interesting rusty thing to do that is not really talked about in tutorials very often. How to hook up some ad hoc wiring together of 2 different build systems. Very rusty type of thing. And also I want to go review the Go bindings. For better or worse, I have not looked at any of the other Tiger Beetle language bindings during this project. I've just been kind of like relying on my intuition about the shape of the underlying Tiger Beetle library to just imagine how the Rust bindings should look. So I haven't really taken any cues from all the bindings that have come before. But I feel pretty good about what I've arrived at here, so I'm not too worried about it. If we do find that the Go bindings are doing anything particularly different, at least we understand the system well enough that a little bit of refactoring will not be particularly painful. But I feel pretty good about what we've got here. All right, so let me think. Bit fields. There's a bit field in some of our structs here, and Rust bit fields are kind of not very pleasant. So I got to kind of decide just how we want the bit fields look to the API. Some stuff to do on the destructors that I've been thinking a little bit about off stream. We might be able to knock that out pretty fast. Test harness, interesting stuff. Fairly meaty project though. Documentation I don't want to do yet. Build system stuff, I have not thought enough about what I want to do there. All right, let's work on this destructor. Let's work on that destructor. So the whole issue here is that we have both a close function and a drop function. This drop function just delegates to the close method. And this close method, I have put it here with the thinking that it would be nice to have like an explicit close and to know that all the resources are freed successfully. Now, whether there are actually like any error cases to handle here, I'm not actually sure. And I suspect there may actually be nothing to do here, but I kind of need to investigate how this dinit function works. The underlying library is parallel. So there's multiple threads going on, and there's synchronization issues involved in destroying the client. And I don't really know what the underlying TB client destructor is doing. But what I kind of suspect, the way this client works is that you submit request, and then the client library has an event loop going on in another thread, and it sends you callbacks on another thread for completion. And so what I've been thinking is like, maybe this destructor, this TB client dinit function, it returns nothing. There's no errors possible here. So exactly what it's doing, I'm not sure, but I'm thinking there may be concurrency issues here where you close the client, but those callbacks aren't finished yet, and those callbacks might continue to run after you've called this dinit function. Like this may not block waiting for all of the other callbacks to finish, or it might. I'm not sure. Because in general, this is a non-blocking API, so I wouldn't expect this to block. I would expect this to like kind of terminate immediately, and then your off-thread work to continue kind of winding down, and then still give you those callbacks for every single request you've submitted, but maybe after you've called this destructor. And if that's the case, I would kind of like for this close, which returns a future, this is an async Rust API, I would kind of like this close just for the user to have the option of closing and then awaiting for all of that off-thread work to actually completely finish. But also, I think there is really no opportunity for bugs or errors. As I have a core assumption that for every request submitted, the TB client is going to post a callback for us to free resources that we've loaned out to the client temporarily. So I assume that is going to happen. Even if we've closed the client, it will send us some callback saying, no, everything's shut down. I didn't do anything. Here's your buffers back. And whether that happens here in a blocking fashion or whether that happens way down here sometime in the future, I don't know. But my assumption is it might happen after we actually call the destructor. But the way we've set up, and we're going to have to document some of the invariants here, the way we've kind of set up the Rust bindings should be foolproof. Like, for example, all of these futures for queries capture the self reference. So if you're holding this future, you're also holding a reference to the Rust client object. And this close method calls, and this holds a shared reference right here. So it's a shared reference. This close method takes the client by value. And what that means is that you cannot hold an outstanding request future and destroy the client. So there's no opportunity for like a future to continue in existence after the client has been shut down, waiting for something to happen. All those futures have to be dropped before you can close the client. And that's enforced by Rust borrow checker. Similarly for drop, Rust drop takes a mutable reference, which is an exclusive reference. And because those futures capture a shared reference, they also all have to be dropped out of existence before you can drop the client. So structurally, we've created a situation where there's no question about like futures holding on to references and expecting something to happen after the client has been destroyed. So that's very nice, and we probably need to remember to document that somewhere. And also, part of the situation, the design of this bindings to the client library is that every time we submit a request to TB client, we take all of our allocated buffers involved in that request and we convert them to raw pointers, so Rust no longer knows about them, and we hand them off to TB client. And then as soon as TB client gives us a callback, we convert all those unsafe pointers back to owned Rust collections so that Rust is responsible for dropping them and freeing resources. So, assuming that TB client always gives you a callback for all requests, even in closed conditions or early closed conditions, you should expect that all those buffers will be freed, even if you don't do anything special to account for outstanding requests. But as I'm even saying this, the structure we've guaranteed here, where there can't be any futures. Okay. So we know there can't be any request futures outstanding when we close the client. So client DNet cannot be called if there are futures outstanding. That doesn't mean, though, that the requests those futures are waiting on are done. Like you can create a request, get your request future back, and then drop the future before the request has actually been handled. And in that case, TB client is going to continue executing the request. It's going to call back our callback in our other thread. That callback is going to reclaim all those buffers, reclaim ownership of the buffers, and it's going to try to send those buffers back to the request future on the other thread, but the other thread is going to not exist anymore. So by the act of sending those messages is just going to fail. The buffers will be dropped silently. But that could still happen after the futures are dropped and potentially after the client is destructed. So that's kind of the whole question here. But there's no real opportunity for like a leak or any kind of error. It's just kind of like the potential that like there is still stuff going on in the background even after the user has closed the client. And I think just for peace of mind, it would be nice for a client to be like, all right, at this point in time, like everything is freed and shut down. To not have any question, there's another thread going on, still calling back callbacks and freeing buffers. But let's look at this. I think the thing I want to do here, I'm kind of suspecting we don't need to do anything here. Like maybe we'll leave the close method here, but maybe we won't do anything. But if TB client is doing callbacks after dinit, then we might put in some kind of synchronization here. Okay, I think I'm explaining this very verbosely, not just for streaming context, but for my own process. I'm trying to understand what I'm going to do here. I think I want to look at TB client dinit and see what it does. I have a suspicion of what it does, and I've seen a little bit of that code. And I actually don't really remember where this code is. It's been a while since we've looked through the TB client code. So I know that tbclient.zig contains some of the client code. Let's look for tb client dinit, and it's not even in this function or in this module. Where would that be then if it's not in there? Maybe it's in here. Don't think so. Let's just do a grep rgtb client d init inside of source client c. All right, do you see it? Do you see it? I don't actually see it in here at all. Is tb client d init not defined? Oh, I know. From the outside, it looks like a standalone method, but I think, or a standalone function, but I think it's a method. You can see right here, there's some method calls to tb client dinit. I find the reading the tb client code a little confusing because there's several files involved in defining what the tb client interface is. It's not all in one place. But as I recall, there's something out here, tb client exports. So this is kind of defining like what the actual symbols are in tb client. And I don't actually know why this is not in the tb client directory. But here you can see there's an init function called tb client init. And if you look for tb client dinit, right here you can see, I don't even know what this does, but there's an export zig intrinsic here. And it's saying, let's export this symbol as a C function. And this must be like implicitly creating a wrapper that is tb client dinit. Or maybe the ABI for methods is exactly the same as the ABI for, no, I don't think so. This must be creating some kind of wrapper around this dinit method. Yeah. Which is, it's just a tiny little, I've run into this. I've been doing this project for 2 months or so. I've run into this little thing. It's a little paper cut, like the tb client dinit function has no definition, right? And it would be very nice if it was just a regular function, but it's kind of wrapped up in this magic. And that's, I guess you'd get used to it if you're a Zig expert. I'm not a Zig expert, but I guess you get used to it. But so far it's it's been a little confusing. Just give me a second here. I'm checking how the stream is looking. I think it's okay. I've spent a lot of time here just kind of like talking and procrastinating. Let's see if, all right, going back to the terminal. Now we can find the dinit function. It's on the tb. Yeah, see, this is not even, it's not even a value type. This is just a module. So this is just saying like re-export this standalone function with this name. Right, yeah. All right, let's not belabor that point. Let's go find that dinit function. Init is right here. So you can see this init function is defined here explicitly for tb client, and this dinit function is not just for tb client. Sorry, I got mustache. I gotta get a haircut. My mustache is kind of prickling up into my nose. Gross, right? Sorry. Let's go find that tiger beetle module though. Let's actually make sure what this tb is. TB client. So again, this is in the VSR. VSR is VSR is kind of one of like the main modules in Tiger Beetle, but VSR stands for View State Replication, which is the words. It's like a Paxos thing. Consensus is the consensus algorithm for Tiger Beetle. And TB client is apparently a module in VSR. I'm sure I've looked at it before, but .zig, TB client. Oh, so interesting. The TB client API is also included in the VSR. One thing I find about Zig is the module structure is kind of spaghetti-ish. Like, I don't really understand. Yeah, you just kind of like pull in modules from anywhere in the file system, and presumably the compiler just kind of like creates that DAG of module interdependencies and finds cut points to not have cycles. I don't really understand how it works, frankly. But, designing a module system in a programming language is pretty tough. Whatever you do is going to confuse somebody. I remember thinking the Rust module system made plenty of sense. And then that was one of the things that people really criticized about Rust was like modules don't make sense in Rust. But I thought it was pretty straightforward. Anyway, so we're going back to tbclient.zig. Let's see, do I have it open? Yeah. So somewhere in here is the dinit function. Okay, so there's our dinit function. And you can see this, most of the surface API in the TB client library defers to what's called a context. And there are two different contexts. One is the echo context, and I don't know what it does, but I hope it's useful for testing. And it just calls dinit fun. So let's go find one of those contexts. Probably here. dinit. Dinit fun right there. Context implementation. dinit. Where does it set up the on dinit? Right here. So there's going to be kind of wondering what this thing is I'm looking at. Okay. This is the general type of context. There are two different context implementations, though. I think this is just kind of like a wrapper around the context, but I'm not entirely sure. Echo client. Well, I don't see another context implementation in the directory. Anyway, let's go look for on dinit. Context implementation. Get context, self dinit. Self dinit. And yep, there's another layer of indirection here that I don't know where it is. Let's go back to the TB client and figure out how it sets up that context. Init and init echo. All right, so there's a default context and there's a testing context. So we need to go find that default context. Where do you live? Default context. Oh, it's defined right here. Client type, client, context type, client. So it's all in this context type. So a context is really just a light wrapper around something that looks like a client. And this is the main client that lives in Tiger Beetle, and this is the echo client. All right, so context type. Let's go back and figure out what it's doing with that on dinit. On dinit. Get context. And it calls dinit on get context. What is get context? What does it do? Get context. Returns a star context. And star context has a dinit function. Function dinit. All right, this is it. So on dinit defers to this dinit function. But one of the types was called a context, and one of the types was called a context implementation. Anyway, I don't fully understand the indirection here, but function dinit in context.zig is the thing. All right, so immediately you can see here's some code related to shutdown. And you can see we're not allowed to shut down multiple times. So in Rust, I think, structurally we've made it so you would not shut down multiple times. But let's go look at this real quick. Yeah, you can see here, this drop, because drop calls close, we have to prevent infinite recursion here. So this is gonna, in our close function, so drop here calls close, and then close takes a client by self, does the dinit, and then down here it's gonna get dropped again. So the close function has to be responsible for stopping that recursion, and it does it right here by nulling out the client pointer. So we're not going to shut down twice. All right, so you can see here there's a cancellation thing. It's going to wake up the other thread. Oh, and it calls thread join right there. So this is a blocking function. That is interesting. This is a blocking function. What does that mean for our Rust API? So on one hand, this is nice because we know that there's going to be nothing happening off thread after this. And probably, we go look at what happens when you send the signal, but presumably all the callbacks get called with some kind of status like canceled or something like that. And we've made it so that the Rust users will never see those cancellations because they have to drop their futures before they close the client. Though I don't know if that design choice will hold because, when you're dealing with lifetimes and futures, having lifetimes in a future restricts how they can be used. And so it might end up that we don't actually end up wanting to hold that client lifetime for our request futures. I'm not sure yet. Reasoning about the combination of futures and lifetimes is really tough for me. Anyway, we don't have to wait here, but this also suggests that maybe we should do this off thread and then wait for this thread because, yeah, this is pretty nasty actually. We really don't want to just block in a Rust async function. And this could block indefinitely, right? It has to, if there are outstanding messages going out across the network, and this is kind of waiting to do all of its cleanup, this dinit function could last forever. I'm really feeling like this close method needs to punt this destructor to another thread. I really think that's the case. Okay, well, that's exciting because that's an interesting thing to do on stream. Let's just bite the bullet and figure out how to do that. So this should be relatively straightforward. You've already taken ownership of the client here. So what we can do is, and hopefully this underlying TB client library, if you could see, yeah. Don't have my right-hand window pane scrolled up for you to see it underneath my face over here. Hopefully the underlying client will cope with seeing this dinit call happen on some other thread. I don't really anticipate that being a problem, but we'll see. So the thing to do here is that, first we're going to have to null out this client pointer probably, and we'll do like a take or replace, replace the sum pointer or replace the real pointer with a null pointer, and then just pull the client pointer out to the stack, and then we'll send that client pointer to another thread along with like a message in order to send back a completion message. And then this close method will just wait on that. And we can launch an entire thread to do that. And I'm assuming, clients are not going to be closing. I assume clients are not going to be closing clients, or users are not going to be closing clients a lot. But, launching a thread is pretty heavyweight. Yeah, so this seems pretty easy. We can just let's make sure we're going to make some mistakes here. So let's make sure our workspace is clean. Okay, so I made some to-dos here. And let's do something different here. And the first thing I want to do is say let client equals stood mem take, maybe. I'm not sure. I'm not sure if I think take will work. Take, what I think take does from memory is it takes a value out of takes a value out of a reference and replaces it with the default value. And this is assuming that the default value for an unsafe pointer is a null. Reasonable. So I'm going to say and mute self.client here. And now we have the client raw client pointer, and the Rust client type is null. So we're nullifying this drop, making that drop do nothing. And also consider that, like, if we do this off thread, then the drop method is not going to wait on the future. So this drop, if you let the client drop, it will not wait for close. And I feel like we have to do that to maintain the async semantics in Rust. It's just a future surprise if we let this destructor block indefinitely. I feel like we really got to make that happen on some other thread. And I'm assuming this thread.join is blocking. It's got to be. It also makes me wonder if there are any other blocking APIs here that we need to be worried about. I assume not, though. All right, so we've taken the client out. Now let's spawn a thread. Stood thread spawn. And we'll make this a move closure to just move whatever we want into this. And a thread can return a result in Rust, so we actually don't need a channel here. Oh yeah, we do need the channel. Like, we can wait on a thread, but that's a blocking action. So we need to not wait on this thread, and we need to use async channel in order to wait for the result. Although, are we using Tokyo here? Tokyo would, we need to be runtime agnostic. We're not going to use Tokyo in this API. So probably can't, I'm sure Tokyo has some kind of like thread-like thing that'll return a result. But we're going to just spawn a raw thread, and we're going to need some kind of channel for it. And real quick, I need to go back and look at our imports to understand. All right, we have one-shot channels with senders and receivers. That makes sense. We're going to send. There's multiple types of channels in Rust that commonly defined in Rust. And a one-shot just says you can use this channel once to send one value. That's what we need. We don't even need to send a value. We can just send a wake-up signal, really, because there's no possible errors to return here. For now, we use a one-shot channel. I know that there's like the Tokyo sync module defines something called a notify, which might be more efficient than a one-shot channel. But a one-shot channel of nil might also be specialized to be very efficient and not require a heap allocation. We'll see. Anyway, a one-shot channel is an appropriate starting tool to use for this. So we're going to say let sender receiver. This TXRX is a common idiom to mean sender receiver equals channel. And this is going to be a channel of nil. And here we're going to capture the channel. And all we have to do here is do this and this is no longer self.client, it's just a client pointer. And then say tx.send, and this could be in this could still be an error because this close, so the send function on most Rust channels returns a value indicating whether the send succeeded or not. And also returning, like if it failed, sometimes they return you the value that you tried to send but failed to send. And generally the only reason a channel will fail to send is if the receiver hung up. And in this case, this receiver is captured in a future. That's going to be down here in this async block. And that future could be dropped. So it's possible that the sender is not actually going to wait for close. Just like in the drop case down here. The sender is going to call close and then forget about the future. It doesn't care. So we're going to say let underscore equals tx.send, and of course underscore in Rust means this is a variable that I'm not going to use. But it also tells it says I know I'm not using this. This send method is going to return a result, which is an error-bearing type, and Rust has a special warning if you neglect to use a result because you're not doing error handling. And this is saying, I'm using that result and just throwing it away. A very common pattern in Rust. All right, so we're going to send it, and then down here, don't need this anymore. So all this runs immediately on close, and then here we're constructing a future. And so in this async block, we just say tx receive, and I think we just say rx.await here. And I don't remember if this can return an error or not for this particular channel type. But let's go look at where else we used rx.await. Looks like it can. So it could be an error receiving, of course, because maybe the sender hung up. And in our case, we would not expect the sender to hang up. That would be, from our reading of the code, we expect that this D in it is going to, actually this is the sender. This code is very simple. In order for the sender to hang up, this would have to panic. And that's not going to happen. Because a panic in Zig is, I think it'll be an abort. I think it's an immediate abort. I'm not actually sure. Does Zig have unwinding? I doubt it. Anyway, it's probably not going to unwind across FFI boundaries. Hopefully somebody will tell me in the code review. But anyway, this looks like the whole thing to me. So we just punt that destructor to another thread. Wait on it. This all looks correct to me. Let's say check. I'm in the wrong directory, guys, folks. Source. Clients, Rust, cargo check. Okay. Like I was talking about before, this take function replaces a value with a default value. And I was speculating, maybe null is the default value for pointers, but it's not. There's no default implementation for pointers. So what we're going to do instead is use stud mem replace. And this takes an argument where we will say stud pointer null mute. This is either null mute or mute null. And that should drop the null pointer in there. And, unsafe pointers cannot be sent between threads safely. I knew that. Was not anticipating that though. How do we do this? How do we do this? How do we do this? I actually, there's a type we have to wrap our thing in to do an unsafe move, an unsafe send. Oh, I forget what it's called, y'all. All right, there's some kind of, let me see, does this tell me? Send is not implemented. All right, we're gonna have to go poke around the standard library to remember what I have to do to move a pointer across threads. Let me just add ChatGPT. ChatGPT will know. Let's go to the webs. Where's my web browser? It would be nice if I had like a voice communication with ChatGPT set up here for the stream, so I could just talk instead of like, typing it out. I don't use ChatGPT all that frequently on the stream. In Rust, how do I send an unsafe pointer across threads? Yep. Wrap the pointer in a safe abstraction. No, there's got to be a standard type for this. Come on, there's got to be a standard type for this. Oh, maybe I can just write an unsafe block to do it? Huh. Wait, what are they doing here? Okay, they're wrapping it in a custom type. There's got to be a type that just says, pretend this pointer is safe. Is there a standard wrapper type for sending an unsafe pointer? Okay. ChatGPT thinks no. Maybe I'm thinking, so for catching panics, there's a way to smuggle, for catching panics, there's a way to smuggle data across the panic boundary. But maybe there really isn't a way to, hey, why? Oh, I closed my browser window. Yeah, shoot. That's, all right, chat, give me 1 second to fix my entire workspace here. Never close streaming windows. Just leave them always open. Hey, Regami, I see you there. So we're just kind of doing some cleanup tasks to get this Rust client library ready for a PR. We're doing a Rust client bindings to the Tiger Beetle database, which is a Zig program, but we're doing a Rust stream. And right now we're just working on handling the destructor correctly, because today we discovered that the client dinit function, which is a Zig function, the Rust client is just bindings to a Zig library. This is a blocking destructor, and our Rust client is an async client, and we don't want to block in an async function. So we're just kind of punting this. Right now we're working on punting this destructor to another thread. And at the moment I'm stuck because I don't know how to send an unsafe pointer in Rust to another thread. My default, unsafe pointers in Rust are not what they call send. They're not sendable across thread boundaries. And this seems like a bread and butter Rust stuff, but it just kind of escapes me like the idiomatic way to do it. I'm sure at some point somebody will see this and tell me why didn't you just do the thing? It should be pretty obvious. But yeah, Regami, I think this is a pretty cool project for streaming. It's a very constrained, but this project involves a lot of very typical systemsy Rust subjects like async Rust, FFI, performance, considerations around allocators, lots of considerations around unsafe code. So we're doing the whole thing on stream, and it'll eventually be a playlist on YouTube. And I'm hoping some people will find it useful. Though this is my first stream, and it's a little bit rough around the edges. This is my first time streaming. I've done this stream 20 times now. This is my first, experience with streaming, so it's been pretty rough around the edges. But I'm hoping to do this kind of thing, like just pick a simple project and do the whole thing on stream and do that over and over for the immediate future. Anyway, we have this unsafe pointer. It needs to go to this other thread, and I've forgotten how to do that in an idiomatic way. ChatGPT just suggested that I should create a whole type just to smuggle that pointer around, which strikes me as totally bogus. Like, it just seems like a lot of extra work to do that. But maybe I could do it. And in fact, what I could do, so I already have this safe Rust type, right? And this Rust type contains this unsafe pointer. Let's go look at it real quick. So this is the Rust client type, and it contains this underlying C pointer to the TB client T. And we haven't really thought about moving this client between threads, but there's no reason you couldn't move the client between threads. So what we could do here as a simplicity is just, let me think about that really quick. So this client, in general, the way I'm thinking this will be used is you'll have the client live in one thread, just doing I/O as fast as it can. And you wouldn't want to share it between threads because there's just not a lot of performance advantage to doing that. I mean, you could maybe, but I would expect that users of this library, if they want to do lots of threads, they'd probably create lots of clients, like a client per thread. And this client is already inefficient because the underlying client needs a second thread. So this client already involves 2 threads at all times. It's got the main thread, which is dedicated to your language's purposes. And then the underlying TB client library has its own IOU ring based event loop on another thread. So I would expect that, and I would recommend probably in the docs at some point when we write the docs, that we'll say, like, if you want to do multi-threaded requests, create different clients. That's what I'm thinking. And right now, the way we've structured this, we talked about this earlier in the stream, is that when you create a future for a request, you're holding this reference. You can see it if we expand this explicitly in the type signature. We're saying the future holds the reference to the client. And that'll prevent the client from being sent around while there are outstanding requests. So there's no reason you couldn't send this between threads. I don't know if I want to do that. So popping the stack, what we could do is just make this send, and you can unsafely say this implements send. By default, this won't implement send because this is an unsafe pointer. And we could say unsafe impl send for client, which would allow the client to be sent. I'm not sure I want to do that because we would be giving the client like that send capability without a real use case for it. And that's just kind of like an extra thing that, like, I don't know how callers would use that. And, maybe that would lock us into decisions in the future. So I don't really know if I want to make clients send after all. I was thinking like, that's the thing to do here, but I think I want to reserve that send capability for future work if somebody asks for it. So what I'm going to do is I'm going to do what ChatGPT told me to do, and I'm going to create a struct just to send this pointer. And then maybe in the review, MattClad will tell me what I missed, what I got wrong, what I wasn't thinking of here. MattClad is a Alexi, very well-known Rust programmer that also works for Tiger Beetle. And he's much more clever than me. And so he'll probably review this and tell me all the stuff I did wrong. And then we can come back on stream later and we can go over what Alexi said. Maybe he'll even do a code review on stream with me. That would be very cool for the stream. We could submit a PR and have Alexi do a code review. That could be very fun. A lot of work though. I don't know how to orchestrate 2 people on stream at the same time, but maybe good learning experience for me. Anyway, I've digressed a lot on this stream. Let's just do the thing we said we were going to do. And this is going to be ugly. Okay, so struct unsafe client contains whatever this was. I just copy. Nah, I'll do it this way. Contains this thing. And then we say unsafe impl send for unsafe client. And actually, this calls an unsafe client is not very descriptive here. Send client. Send client. And I think this is send is a marker trait, so there's no methods to implement here. And I think this is the syntax for implementing an unsafe trait. ChatGPT just told me, and I didn't really pay attention, but the compiler will probably tell us if we got it wrong. So here I'm going to say let client equals send client of client. Notice we're just shadowing the previous definition. This is a very common pattern in Rust. We're shadowing the previous definition and changing the types. You know, by changing the types, it kind of almost completely rules out the possibility for errors. A lot of people think shadowing is a anti-pattern, but in Rust it's a pattern. And I'm just beautifying this code a little. All right, so now our client is captured and it's sendable. And we should just be able to say client.0 here. And this should work. Honestly, this was not too bad. Just 3 extra lines to do this thing. Let's check that. Wait a minute. Send. What did I do wrong here? I did what ChatGPT told me to do. Oh, wait, no. No. Why didn't this work? Std marker send is not implemented for that thing, but I'm actually quite confused here about what I'm seeing here. I'm not capturing C void. This error message is not great. It's not telling me where the capture is. There's only 2 things being captured here. Is the channel. Can that channel not be captured? Spawn. I'm not trying to capture a C void. This client pointer is a C void. Ultimately, it's a type def of a C void pointer. But I put it in that struct. And so I'm expecting that struct to be captured. But maybe because I only did a field access on it, it's capturing. Maybe because I only did the field access on that wrapper, it's only capturing the field of the wrapper. That seems very strange to me, but let's test that theory. So again, up here, we're capturing this, but let's say let client equals client and make it explicit that we're capturing send client. And then we'll pull the field out. And let's see if that builds. I'm going to be very surprised if that is. I was surprised. Indeed, I was surprised. That is a surprising semantic. That is surprising. All right, let's recap what just happened here. So what I'm trying to do is move this unsafe pointer called TB client. This is an unsafe pointer to another thread so we can call a destructor on it. You can't do that directly though because unsafe pointers in Rust are not sendable. They don't implement send. So what I tried to do was create a little wrapper type here and unsafely say this wrapper is sendable. And then I tried to capture the wrapper in this closure that gets sent to the other thread. So this client here, this is a field access of that wrapper around the unsafe pointer. But this didn't actually work because the wrapper didn't get captured. Only the field got captured. And that is not really what I expected at all. I expected, because I mentioned the name client, that the entire client would get captured. But this is surprising semantics to me. But probably what's happening is that there's some kind of analysis saying, what are the fields being accessed? Let's destructure this entire struct and give you only the things you're accessing. And then you could keep accessing the other fields down here probably. Like each of those fields is kind of like a path that is analyzed independently. But that, maybe probably that's a useful thing, kind of enables things to happen just work. It enables some kind of just workiness. But as a result, this didn't really behave the way, my simplistic brain thought it was going to behave. This is also true in Rust with a lot of things around borrowing, where it's like the simple intuitive model, or the simple model, is too restrictive. So there's a whole lot of control flow analysis to try to make the model less restrictive. But as a result, you can't intuit nearly as easily how it actually works. So the complexity of the control flow analysis might enable more just workiness, but it also disables your ability to reason about what the compiler does. Anyway, this is very surprising to me. But it's also ugly. Now I have to just put a explicit assignment here just for the capture. There's no capture clauses in Rust like in C++. In C++, you might say, like, I'm capturing client, though I don't remember the capture syntax in C++. Anyway, this should work. Let's go check that one more time. And now we probably need to go run our smoke test and make sure this actually still seems to work. Let's go look at our main function. This is just a handwritten ad hoc smoke test that does some stuff. And the smoke test doesn't actually call close anywhere. But let's change one of these to close the client and then await on it and make sure everything still seems to be working. Say client.close.await. And actually, before we do that, this future close, there's no possible errors for this to report. Although we do have a question mark here. I believe this case is impossible. So this question mark here would happen if the sender disappeared, and the sender is right here. And I don't think there's any way for this code to not execute. So I think this is destructor thread disappeared. Not possible for that error. So this is no longer going to return an error or a result. It's going to always succeed. I'm using here our drop method. Drop is not waiting for the error anyway. Let's check that. No longer need to return an OK here. Okay, now let's run our test program. We have a close here that we're testing, and then all the other functions are just testing the drop method. Seems okay. We need to run a server first. And we've already got a test database that we've been using for a while now. So let's run this server. And then we can run our main program. And this is very interesting. I talked about this last stream. These are historical request errors. And they're just kind of hanging around the database. I don't really know what that's about. Let's run our program and see if it doesn't crash. Okay, seems to be okay. And let's add a comment about why we jumped through all these hoops in the destructor. Good enough. And we'll probably put something about that in the doc comments as well eventually too. You know, for this type of code, we really want the user to understand all the performance trade-offs being made. So this hidden thread is pretty crazy. Just spawning a thread for this one little thing. Okay, but we can knock off a to-do. So we've accomplished a thing. Let's look at our other to-dos. Actually, let's take just a step back, regroup. And give me one tiny second. Forgetting what all my scenes are. I was just applying some lip balm. Thought that was a little too suggestive and sloppy to do on cam. Happy to sip my drink though. I'm just going to pace around for a second, breathe. That's part of the hacking process, is taking breaks. I want to keep on the mic here. I want to put another camera way up in the corner here to get like a wide view of the studio. I'm really focused on streaming and this building out my studio here, which I also use for music. And I want to put a camera up here to just capture more of the space so that when I'm not like when I'm just like hanging out, pacing around, you can kind of still, see the space. It's kind of like a peek behind the curtain. I think that'll be a pretty cool second camera to have. Okay, let's stop procrastinating and bite the bullet and do a thing. Switching back to the code. Do something about bit fields. No. Create test harness. Maybe. Write some API docs. Nah. Wire up build system. I need to think a little bit more still. Again, mustache issues, guys. I really need to get a trim. This is a very nose-centric stream today. Review Go bindings. Bit fields. Create the test harness. So the test harness is something I know how to do offhand. Bit fields we can go investigate, actually. Let's do the bit field thing. Okay, y'all. So to recap what the bit field thing is, let's go look. Several structures here. So this is one of the core data types in Tiger Beetle. And this is just a Rust read definition by hand of the core data type, of the account type. And this is a bit field. And there's a bunch of constants defined for these flags. And we have to decide how we want to present this to the user. You have to decide how you want to present this to the user. Is this just an integer and they have to use the correct constants with it? Or is it more of a structured bit field type that is maybe less error prone, but maybe has some funky macro-based syntax? And there's another consideration here that we probably want to leave open the possibility that this, let me open my other window here, tbclient.h, TB account T. So this is a mirror of the C data type. And we probably want to leave open the door to making this account struct have the exact same binary representation of this TB account T for performance optimization. So far I'm leaving this to have the exact same fields, including leaving in this reserved field. Partly for the sake of documentation. So when the user sees this in Rust, they can be like, okay, this is account, this is TB account T, and they can kind of like read the core Tiger Beetle docs to understand the Rust API. You know, if this had a bunch of transformations, like not having the reserved field or something like that, and then it may be hard to understand the relationship between the two. It gets harder and harder the more niceties we add on top of the core API to understand the relationship between the Rust API and the C API. And so we have to decide what to do with these flags. This timestamp is a similar problem. Right now it's just a number, and it could be some structured data type. And probably we're just going to leave it a number because I don't know how users are going to use this, as it says in this to-do right here. And in fact, I think I'm just going to delete this to-do. I don't care. I'm pretty determined that this timestamp is just going to be a number. But flags could be something else. But a consideration here is that we might want this to be repr C. And if we pick some other abstraction for flags, we're going to want to make sure that it's compatible with the underlying U16 representation. So that's the big question, is like, you know, whether any of the Rust abstraction for bit fields has guarantees about the representation and whether we can still tag this repr C in the future. Let's just go refresh our memory on what the Rust options are here. So the basic problem here is that Rust doesn't have a lot of support for bitwise access. It has no language level support for accessing bits. You can do bit math in the old-fashioned way with, you know, bit masks and logic operators, bit logic. But there's no language level support. And that's one of the areas where Zig is definitely nicer than Rust, in that you can do like 1-bit values, 1-bit fields, and they just integrate it with the language. Std.rs is not what we want to do. We want to go look at Bitflags. This is the most popular way to do this kind of abstraction in Rust. And you can see that it's a, I think this is a procedural macro. There's a few other alternatives though, but really probably if we're going to introduce a crate for this thing, probably just use the most popular crate. So here you could say, you know, here's our bit field, and you can specify what type it is. So presumably this will compile down to being literally a U32, or more likely it'll be like a unit struct wrapper around a U32 that has the repr transparent. So it's a struct that looks like a U32 at the binary level. And you can see right here, here's an example of the generated code. Let's go check that out. What is it? The flag type. This flags. The struct flag. Oh. I'm assuming this is repr transparent, but this doesn't say in the docs. Maybe the docs don't indicate the repr of things. Maybe? That's important info. Let's look at the source here and see if this says repr transparent. Ooh. That. Gross. Maybe this is not repr transparent, but maybe you can add yourself the repr attribute and it'll sync down through the macro and make it transparent. Questions? I'm kind of feeling at this point, the fact that you can define the integer type, maybe we'd try to make this transformation and see what it looks like. Just, do the work and just see how it feels to us. So let's do that. And then we'll see if we can make it C. And let's see, how do I want to do this? Because I'm going to have to, anytime you're dealing with a macro, you got to do a lot of cross-referencing of what the actual syntax is. Source may set any bits. Okay, that's weird. We also got to consider that if we do this, we need to be able to define a default representation or a default implementation for these flags. Derive, oh, here's some derives defined directly by this macro. Derive some trait. ByteMuck. I don't know anything about the ByteMuck crate. Custom methods. Okay, so you can just define your own impls on the type. That's good. So we can define default if we need to. Okay, I'm just going to copy and paste this example. And we're going to give it a shot. Let's see how it goes. I'm not convinced yet, but let's give it a shot. Remember, we need to go back to our code. All right, we're back at the code so you can see what I'm doing. And we need to add the Bitflags crate. So I'm going to say cargo add Bitflags. You can see there's a bunch of features that we're probably not going to need. You can disable the stud, or you can, okay, stud is off by default. We probably don't need. Let's look at it real quickly, see if that doc explains what stud is doing here. I don't care, forget it. We're not going to need many features of this crate. So we're going to import use Bitflags, and then let's go. I'd really love to just do it inline here, like say Bitflags, but don't think we can do that. So we have to define a Bitflags thing. And all right, remember I copy pasted. Here's some Bitflags. And this is going to be account flags. And account flags is a U16. And now let's go look at our C code to figure out what our flags are. Probably TB, just looking at the patterns here, account flags. There we go. There's all our flags. Yeah, makes sense. So what we can do here is say const TB linked, and then we can probably just assign this directly from TB account. All right, remember this on the right-hand side here, what we're seeing is the C definitions. And from previous streams, when bindgen, the Rust C bindings generator, translate this, it's going to translate all these to constants, and they're going to be prefixed like TB account flags. They're going to be prefixed with the enum name. So there's going to be TB account flags, TB account linked. And this should work. As I'm writing this, I'm kind of liking what I'm seeing. And then here we're going to say, actually, let's just compile this and make sure that this works. Check. And I'm not going to compile our main test program because that's not going to compile anymore, but I'm going to say cargo check Tiger Beetle. Expected, okay. So this is another, we've run into this problem many times where C enums are generally U32s, but this field is a U16. And I don't know if this works or not. This is a const context, so I don't know if this cast here. This is a narrowing cast from U32 to U16. I suspect that'll work. Yeah, okay. So casting to U16. Now we can just duplicate this logic for all these other variants. Is a const debits must not exceed credits equals this thing as U16. And this is const credits must not exceed debits as U16. Const history equals TBC that. Const imported. Wonder what that means. Const. I mean, I can guess what it means, but don't know why you would need to indicate it. Closed equals TBC. TB account closed. And these are semicolons, not commas. Cast them to U16. Let's see if that builds. Oh, right. These all need to be prefixed, just like I was just talking about and forgot. This is TB account flags. TB, I just remembered another thing we need to put on our to-do list, chat. TB account flags. Hey, thanks for joining us, A7JD8A7K. I'm glad you came, and I'm glad you, left a comment. Hope to see you again. TB account flags. I'm going to be doing this stream. There's going to be a lot more of this stream to come. I expect we'll be working on this project for months still. TB account flags. And the stream's only going to get better as we learn how to stream better. Maybe one day we'll be the premier Tiger Beetle stream. I was going to say the premier Rust stream, but this is the Tiger Beetle Twitch account, so we're not going to be doing a lot of Rust after this project. I'll be back to Zig. But maybe one day this will be the premier Zig stream. I'm not an expert Zig programmer. I'm a novice Zig programmer. All right, let's see if this builds. Okay, that builds. Let's do one more test here. So this is not going to be repr C by default, I'm assuming. So we shouldn't be able to put a repr C here because because that bit field, repr C, I think that bit field is not repr C. And again, one of our tasks here is to make sure that we can make this account have the same representation as the C definition, even if we give it a, I haven't actually put our account flags here as the type. This is an account flags. Let's see if this checks. Okay, so that doesn't check yet because we have a bunch of conversion functions that we have to deal with at some point. And interestingly, by default, our flags do not implement copy. So let's resolve that first. Probably, I'm guessing that we can just, sync attributes into this struct and it'll just work. So you can probably say derive copy clone on this, because anytime you implement copy, you have to implement clone. Okay, so that works fine. This doesn't implement debug either, according to this error here. So let's do the same thing and just derive a debug. Okay, and so now our conversion functions are no longer correct. And we have a whole module dedicated to just hiding all this boilerplate conversion stuff. These are just implementations of from. What lines are we looking at? 17. So this is converting from the C type to the Rust type. And I am going to guess that this macro gives us access to the field of our flags. And I'm going to say account flags, other flags. So I'm guessing that our account flags is a unary struct and that we can see this field directly. So we just wrap the U16 in an account flags and we will get our account flags. But don't know if that's the case. Okay, that is not true. It is not just a plain wrapper around a U16. You can see here there's an internal Bitflags type there. Let's go back to the docs and see how it wants us to convert between the two. Although, as we have learned on this stream multiple times, if you don't know how to do conversion, you can often just wing it and type into, and it'll just work. Into is the most common conversion function. Into is for infallible conversions where there's no case where the conversion will fail. In this case, I suspect there are bit representations that are not valid bit fields in this type, so probably we can't just call into, but let's ask the compiler. Yeah, and it tells us there's no into for this conversion. But we might be able to do try into, and then we could say expect account flags. And this, we would never expect this to fail if we've written our code correctly because we have accounted for all the possible flags that the server might send to us. This could fail if, yeah. I was going to say this could fail if somebody else some other code tried to convert a TB account into an account, but our API is not going to expose this TB account type, so it should be structurally impossible for that to happen. And let's see if this works. Try into from, it's not in for account flags. Yeah, doesn't seem to be implemented. Try into doesn't seem to be implemented either. I was going to suggest, maybe there's even more things we could say. We could say try from, like maybe into is not implemented, but from is. But I think it's time to admit defeat and go look at the docs. All right, we're switching over to the docs for Bitflags, and let's just see. Adding custom methods, working with flags value. Flags values, flag types, bits types. Known and unknown bits. 0-bit flags. Huh. How do you do it? I didn't see anything obvious here about converting from this type to the flags type. There must be something, though. It must generate something for us. It has known and unknown bits. So it's possible to say, like, there are bits in this type that are not defined explicitly. We can add a custom conversion method, but we're going to have to open code all that. There's all this bit math defined. Formatting and parser. Parsing. Oh, text, I don't care about that. None of this. Known bits and unknown bits. All right, if you're using bit flags for flag type defined externally, you probably want all bits to be considered known in case that external source changes. I disagree with that. I would rather write a test that guarantees that the external source doesn't define any bits we don't know about. Yeah, I don't want to do that. I'm not going to do that. One of the things here that you have to do, wow, was that English? One of the things here that you often have to do when doing with the FFI is to write tests that kind of guarantee that one representation, the FFI representation, is the same as the Rust representation. So when we write our tests for this, we're going to write some tests that probably literally go parse out the C definitions of some of these types and then just dynamically figure out whether all the things are the same or not. Although that is, yeah, something like that. Something like that. I'll have to think about that before I attempt to do it on stream. Iter yields the bits. I maybe name a defined flags value a struct flag. Okay, that is some other purpose. Traits flags. Let's go look at their example generate. This is, this is giving me second thoughts about this whole endeavor. Because for somebody to use these flags, they're going to have to come read this Bitflags documentation. That's kind of not unreasonable for, it's kind of not unreasonable for a Rust programmer to have to understand this crate specifically. It's a very common crate. All right, this trait flags. Let's see if there's anything here that looks like conversions. You can get the bits out of it. From bits retain seems pretty likely. Convert from a bits value exactly. No possibility for error. But again, we're going to write tests that guarantee that it's impossible to have any kind of error here. So from bits retain seems possible. Though from bits, I bet this will return a none if the unknown bits are set. That seems like the thing to do. And then we can write one of those expect methods to assert that we have gotten a correct conversion. So this is the thing. This is the thing. All right, let's go back to our code. From bits, from bits, from bits. Here we can say account flags from bits dot expect account flags. That seems like it'll work. And there's one more thing, one more conversion to do here. Where are we? 37. This is converting from the Rust type to the C type. So I'm guessing the bits function is going to do that. And all right, there's a little bit, oh, this is our main. Yeah, I can't avoid type checking main as well. I don't want to deal with that right now. This is in our little ad hoc test case and doesn't really matter to me right now. But all the rest of it type checked. So let's go back to our library. And the big question is here. Big question here is whether we can put repr C on this. And I'm guessing this is going to fail because I haven't said the representation of account flags. Oh, it did not fail. Huh. I'm curious why that is. Does account flags, so we've already got account flags here. So this, the representation of this has got to be representable as C for this to be repr C. I wonder if the docs just don't show it, but this account flags might be just defined as repr transparent, which would make a lot of sense because it would just transparently enable you to do this use case of making repr C. I'm a little concerned though. I really want to know that this has a defined FFI representation. I think the compiler would tell us if I was making a mistake here. I think it would complain if this was not representable as to C. I think. But I'm not sure. Let's see if we can put repr C on this one. Let's see what happens if we do this. Still seems to work. What if we put repr transparent here? That's actually what we want is repr transparent. What if we put repr blah here? Okay, it doesn't like that. Also remember that this account flags, the generated struct here, is not directly containing U16. It contains another struct inside this struct. And for this all to have a defined representation, all those structs have to be tagged as repr something. Let's go back to the let's yak shave a little. I'm just curious. I want to look at that macro and see exactly what the Bitflags macro is doing. So let's go back to the browser. So here's our Bitflags crate. And the macro, let's go find that macro. This is probably a macro rules. Oh, here's the whole macro. No, not the whole macro. There's a lot of the macro. So this is defined by macro rules, so it's just Rust code. And I'm not going to try to figure out what this is. Let's go look at the source code. And here it's reproducing the attributes on this type. So you can specify your attributes and it'll be reproduced on the flags type. And then, okay, this is interesting stuff here. So there's two, okay, let me see here real quick. Let me real quick look at, Rust macros are very hard to read and I don't really understand them that well. I just want to look at all the cases. So this is all pattern matching for the syntax of the Bitflags macro. And this is the output of the Bitflags. Okay, well, there's a whole bunch of stuff thrown onto this. And oh, this is just a constant expression. Interesting. This is a very useful, mysterious pattern in Rust. I don't know if any books teach you this. You just kind of got to learn it. If you want to write a bunch of const expression code, compile comp time code in Zig, this is like creates a unnamed expression, an unnamed value defined by an expression, unless you just write arbitrary code here. Not nearly as expressive as Zig when it comes to comp time. Okay, but this was the first case way up here, and there's another pattern down here. So there's two possible patterns in this macro. And real quick, I just want to kind of understand which one we are using. They look similar. I'm going to go back up. This is, again, the two different, oh, there's three different patterns. There's empty Bitflags. So here we have, so this is a pattern that allows you to define an impl. So this is defining a struct and then some more tokens. And this is defining an impl with some attributes and then some more tokens. Struct Bitflags. Okay, so I think basically, oh, this is interesting. So it's a Bitflags, impl Bitflags, and then it lets you define this constant type on the flag type on the inside of it. I actually don't know the difference. I don't know the distinction here, but this is the one we're using, I think. Let me actually go look at my code real quick. Switching back to the other screen. Yeah. So this is the version we're using. Let's look at the source again. And again, I just want to see whether it's tagging any of these structs with any attributes. Okay. Unfortunately, we can see right here, it's deferring to another macro inside the crate. So to understand this, we're going to have to go dig out this macro. Bitflag consts that are defined. Bitflags T. Don't know what this is, but this is our struct right here. But the struct is, this struct is actually emitted from this macro. So let's go try to find. I'm interested in this topic. We don't really need to do this, but I'm kind of just interested. So let's go look at find where this Bitflags declare public Bitflags macro is, and just keep digging in. Yeah, Scott says there's a book called The Little Book of Rust Macros, which is dedicated to this particular type of macro rules, declarative macro in Rust, and it is kind of the best resource on how to write these macros, but it's incomplete. It's not to say don't use it. It's the best resource for understanding Rust macros, really, at least declarative macros. I think I look at it from time to time as a reference, but in general, I just kind of wing it. rarely write these types of macros. One time I defined I wrote a crate that was declarative macro based, and I had to learn a bit of these types of macros, but they're pretty brutal. Like it's its own little DSL inside of Rust. It's a whole nother language. Anyway, kind of getting distracted here and forgot. I don't need to go research a whole lot about what macros mean for this particular purpose. We'll figure it out by just digging through this code. But let's go look for this declare public bitflags. There's an internal macro, so finding that's going to be pretty ugly just browsing the source code on the API docs. All right, there's no imports up above this. Declare public bitflags, let's just search for it. So this file here, you can see from my title bar, URL bar, this is libs.rs and bitflags. Declare public bitflags. This is the only appearance of that macro. Import bitflags. Is it doing a macro? Yeah, okay, there's a macro export there. Macro export, macro use, okay. The macro system in Rust is very old, and it was kind of cobbled together to get it out the door. And so there's this special macro use thing that says, it's like a special import syntax just for declarative macros. So probably in this internal mod, we'll find the definition of this declare public bitflags. And I don't know. Okay, there it is. Declare internal bitflags. Yeah, declare internal bitflags was probably what we were looking for. Impl internal bitflags. Struct. We did it. So the whole exercise here was to figure out whether these structs are repr transparent, which we hoped, because we need these to have a transparent representation in order for them to be valid to send through an FFI. And there we are, right there. This struct is repr transparent. And yeah, this is it. This is the internal type. So declare, remember there's two types involved here that we've learned from this macro. There's the type you're defining, and then there's the internal type. And the internal type is repr transparent. So maybe the bitflags doesn't actually specify the representation. Probably they don't specify the representation of the visible type, the type we're defining, allowing us to tag it repr transparent. But the internal type, it is conveniently saying is transparent. So, this type here that is internal and we're not allowed to see, without repr transparent, it would have an undefined Rust ABI, and we wouldn't be allowed to pass it through a FFI. But because it's transparent, it has the same representation of whatever this T type is here. Okay, so that was useful, and it worked out. Now we have confidence that we can make these bitflags repr-C compatible, but we don't need to do it right now. So I'm kind of feeling good about this direction. It does mean we have to bring in this bitflags dependency, and users have to understand this bitflags dependency, but it'll probably be more ergonomic, and we can test that right now. So let's go to our, let's swap windows here to put the API on the right-hand side. Window swap, and then over here, let's go to our little test program. And now let's see what these errors are and try to use this flags API. So go to line 48. And again, we haven't derived default on this. And it seems like we probably should. Maybe not, maybe not. Maybe not, I'm not sure. How do you create an empty account flags? Let's test that. Thank you, Regami. That is my most common streaming mistake. Forgot to show you what I'm talking about. Thank you for helping me. So the question I'm talking about now, so here's our errors. We have errors in our little test code because we're not using this new flags API. And the thing I'm speculating about is how you create a 0 value for account flags. But let's just go experiment with it. So this flags is now a account flags, and we're looking for the history flag here. Account flags history. And let's just see if this is the right syntax. I think it is. It is. Okay. Let's go find the other one too. This is TB account flags history. And this immediately looks better than what we were writing before. It seems to work. And let's run it and just make sure it doesn't crash. But I feel confident about it. Yeah, so this is looking pretty good. I'm feeling all right about this. But I'm wondering, like, if you don't care about the flags. First also, let's test, let's make sure we understand the ergonomics of combining flags. Probably going to be TB account flags imported. Let's try that. Yep, makes sense. That works. But what if you don't want a flags? Sure, like you can't put a 0 here. How do we create a no flags? I want to say something like TB account flags none. I wonder if that's not going to work, but we could write in our definitions const none equals 0. This would probably work. Let's try that. Yeah, it works. But I'm not sure if that's the idiomatic way to do that. We might want to say default. Probably just saying default is really what you would expect. And we're not going to get a default by default. Can we derive default on this? We can. We can just derive default. And presumably that's 0. But let's just test that real quick. Let's say assert EQ 0 is account flags default bits. I'm going to run this. I just forgot to namespace it. Yeah, seems to be correct. Okay, so to get the 0 flags, we just derive default. I'm feeling pretty confident about using the Bitflags macro here now. So let's just look at our diff and take stock of where we are. That is interesting. Our lock file changed from version 3 to version 4. I am not sure why that is. Probably because I upgraded Rust since the last time I added a dependency. So this all looks okay. I don't know if that's where I want to put the Bitflags account flags definition. That space I don't care about. I haven't run format or Clippy on any of this code. And I think that is the to-do I mentioned I wanted to add. We need to run format and Clippy. We're preparing to submit a PR here, but it's looking like it's going to be another week or more before we actually get there. Bitfields we're not done with yet. We've only done one of the flags. There's another flags definition somewhere. I think it makes sense to define this account flags right here. I kind of want to know what this looks like in the docs. So another consideration is we want our docs to be very pristine and to be very understandable. And anytime you're dealing with a bunch of macros, what do those docs look like? So real quick, before we continue, I'm going to say cargo doc. And we're going to go look at those documents. We're going to look at the documents, is what I'm saying. And let me make sure I've got my, HTTP server running. It's all my workspaces in Tmux. I have HTTP server always running. I'll show you. It's basic HTTP server, my own HTTP server. It's very useful to have an HTTP server running for reading your docs. Where was I? Tiger Beetle. All right, let's go look at the browser again, and remember we need to switch back when we're done. It's going to be localhost 4000 / Tiger Beetle. And my HTTP server serves Markdown and serves directories. So like we can go look at our Markdown files, which is, we're always writing Markdown files as developers. This is our Tiger Beetle directory. So we're looking for source, clients, Rust, target, doc, and our crate is called Tiger Beetle. So here's what our docs look like. And this special type is account flag. So I'm not seeing any, these are all the re-exports of the C flags types, which we're going to be able to get rid of. This is actually looking very pristine right now. I like what I'm seeing. This is our Bitflags type, but you can see that I'm not seeing any other like junk types showing up here, right? Sometimes when you have macros will spew out a bunch of types and a bunch of stuff that you're not intended to use, but I'm not seeing that here. Here's our account flags. This is all looking not incomprehensible. And actually, this is quite lovely. This macro has been around for a long time, and it's used by a lot of projects. So it seems like it's been taken care of pretty well. This is actually gorgeous. This is a gorgeous output for a macro. The only thing really ugly here is this. But this is actually probably just how Rustdoc shows these associated consts. Anyway, this is great. I'm feeling pretty good about this macro. All right, we're going to go back to the code. We're not going to forget to go back to the code. And again, remind ourselves what's going on here. Oh, I added another to-do. Let's checkpoint that. And again, my history while I'm just hacking is just garbage. You'll see, if you look at my GitHub, you'll see most of my projects have history that looks like ... because they're not production projects. Like if I'm contributing to like a production code, then I make nice history, but a lot of my personal code is just checkpoints like that. And we'll clean up this history before we PR. All right, so we have one more flags somewhere. Flags fields. We have 3 more flags fields. 1, 2, 3. Okay, well, let's buckle down and get this done. I'm going to stop jibber jabbering and let's get all these flags done. First, I'm going to get rid of this to-do about timestamps. This flag's no longer a to-do. And let's copy and paste this declaration code. And this is going to be transfer flags. And now we go find our C header file. client.h. Look for transfer flags. We're going to copy these. And now it's data entry time. My favorite part of the stream, because I can just turn off and just chat brain. I have to keep talking. Okay, doing the data entry and continuing to talk is pretty tough. So we need const linked equals tbc tb transfer flags const pending equals tbc tb transfer flags const post pending transfer equals TBC TB transfer flags. Oops. Const void pending transfer equals TBC TB transfer flags. I'm just thinking that it's very nice that like the Tiger Beetle API is very concise and very clearly and consistently thought out. Like I can kind of just know that the transfer type, the flags associated with it are called TB transfer flags. And it's very easy to just intuit how things are named. Everything is consistent. This is a modern API designed for language binding. Balancing debit equals TBC TB transfer flags. Const. I've been thinking a lot recently about just creating like a little language that transpiles to C that is just for like defining FFI interfaces. I'm sure there's things like that already, but C is, so big, and like if you're defining an FFI in C, you want to stick to a few consistent patterns. There's best practices for designing APIs for binding. I'm screwing up while I'm chit-chatting about other things. This is TB transfer flags const closing debit TBC TB transfer flags. I'm feeling good about how much progress we're going to make today. Closing credit equals TBC TB transfer flags. Const TBC imported equals TBC TB transfer flags. And now let's type check this. And we made mistakes. Oh, right. We need to cast these U32C constants to the U16 representation. As U16, as U16. I'm just saving that in Emacs register so I can just use my, I was going to say I can use my muscle memory to really quickly just do that over and over, and then I completely screwed up my muscle memory. R, X, I, S. Nope. Oftentimes this happens to me in Emacs where I'm like, the thing that my fingers know how to do, they forget how to do it. R, I, there we go. Nope. All right, retraining my fingers. There we go. Inserting the text from an Emacs register. Let's go. Okay, that all type checks. Now this has to be a transfer flags. And there's going to be errors, and we'll just have Rust tell us what the errors are. Line 58. This is converting from the C type to the Rust type, so we need to do C type to the Rust type. We need to do transfer from bits. Look at the code we wrote previously. From bits, right like that. From bits dot expect transfer flags. This should be impossible if we write the code correctly. And another one is down here, and this is going to be flags other.flags.bits. Let's type check that. And I did something wrong. Okay, just I put the wrong type there. I wrote transfer, and this is transfer flags. And then in our main program, we don't have those. We need to change the syntax we're using. So line 105, This is going to be default. Okay, there we go. Let's see, we've done this for 2 hours. And we have a little time left. I'm determined to get through this. Let's checkpoint and go back to our library and find our next flags. This is easy. And let's copy this declaration. And this is called account filter flags. Let's go find our C definition of account filter flags. It's right there. Do it all over again. Const debits equals TBC TB account filter flags. Const credits equals TBC TB account filter flags. Const reversed equals TBC TB account filter flags. And I think that's it. Let's check that. And oh, that is not, again, got to cast, do the cast as U16 and as U16. Again, I'm attempting to use my muscle memory to use Emacs registers. I keep hitting the wrong thing though. I'm going to get this down. X, R, I, S. That's Emacs. X, R, I, S. Inserts that text. I can't ever leave Emacs. I've tried. And this is, my fingers know Emacs, kind of. Emacs is so complicated and it's such a bad IDE. It does not compare to modern IDEs at all. You know. But I'm stuck with Emacs forever, I think. I tried to get out of Emacs recently and I came back. I tried to use Doom Emacs, which is a big configuration framework for Emacs. And I know I'm procrastinating. I tried to switch to Doom Emacs, which is a big framework for configuring Emacs in a more modern way. But, you know, because it's a framework, you have to learn a bunch of Doom Emacs stuff on top of the Emacs stuff. And then I found that it was doing too much. Like it turned on all this fancy stuff for every language. And so you had to, and every language in Emacs has, you know, different modules and different conventions for how they deal with IDE type integrations. So there's no consistent thing you can understand about how the IDE works to understand, like, you know, why your completions in Rust are different from your completions in JavaScript and things like that. Just every single language has a different configuration. And I was finding it was turning on way too much stuff for Rust, and my screen was just filled with noise all the time. And then, of course, you know, when you want an LSP, the LSP has to be set up correctly, and maybe it doesn't work correctly. Just a mess, just a big old mess. So I took a few things that I liked about Doom Emacs, and I just kind of added into my own configuration for Emacs. I also tried Zed for a minute. I like the idea of Zed. But one of my big requirements for IDEs is that I want to be able to use the terminal because I shell around a lot, and it's nice to just have the same IDE in every environment. And I know a lot of modern graphical IDEs have some kind of server, like client server configuration, where like maybe you could shell into another machine and then launch the server and then have it communicate with your local graphical client. But none of it's so standard. Like the way my Emacs works, I just make sure I install Emacs everywhere, and I can just shell around and have the same editor everywhere. Yeah, it's a shame. I would really love to use some of the modern LSP stuff, but oh well. Let me go back to my code here and keep going. I know I keep procrastinating. I complain that like streaming hacking takes so long, but then at the same time, I just stop and just talk and recontextualize and back up and yak shave. Love hearing my own voice. That's not true at all. I don't love hearing my own voice. All right, where were we? This looks like it's probably more or less correct. And it seems to have been. Why didn't I have to write any conversion functions for this? Account filter. Did I not? Let's see. What does our diff look like? I don't have any conversions for account filter. Oh, I have not plugged it in here. Account filter flags. Now let's check. Line 96. All right, here we're creating the C type from the Rust type. So we say .bits. Oh, interesting. These flags are 32 bits. That is interesting. All of the flags we've run into so far, let's go confirm that. What is account filter? TB account filter. Yeah, right here, flags. Interesting. These flags are 32 bits. Other flags are 16 bits. I can't even imagine like a reason for that. Like we could have just, oh, it's for alignment reasons. I was going to say, why not just make this reserved 2 more bytes? But there's, these types have alignment requirements. So there's 2 extra, wait, 2 is 2? 16, 24, 30. Yeah, 2 more bytes. If this was 16 bits, there'd be nothing else to do but just add like 2 more bytes right here. So probably this wants to be exactly 128 bytes or something like that with an alignment of 8 bytes, I would guess. And these have to be aligned to 8 bytes. This has to be aligned to either 8 or 16 bytes. So you can't just stick another 2 bytes here because these would not be aligned correctly. Something like that. Okay, we got our flags over there, and these are 32 bits now. And now these don't need to cast a 16 at all. These should just be correct. And it's assuming that the enum type in C is always U32 on all platforms. I don't know if that's, I don't think that is spec'd in C. I think it's implementation dependent, but probably true that all C enum variants are U32s. Okay, so we got to go change our main function. 142. Okay, so this is going to be flags is TB account filter flags debits or TB count filter flags credits. And then there's another one on 165. Let's just copy paste this. 165. Check that. Commit that. And I think we have one more flags field. Let's get through it. Right here. Copy this declaration again. Make sure there's exactly 4 spaces here between sections. It's my preference. And this is going to be called query filter flags. And this is going to be a query filter flags. And let's go look at TB account query. Oh, it's right there. This is another 32-bit flag. So 32 bits. And there's only one flag type here. Const reversed equals TB query filter flags underscore that. Let's check that. And I type something incorrectly. Query TB query filter flags TB query. Oh, I need to prefix it. I need to prefix it with the namespace TBC. All right, now we have a conversion function. Line 126. This is going to be .bits. Yeah, .bits. And then finally our main function, main module, flags. This is going to be default. Git commit. So we did all the flags, and now we can cross this to do off the list. Whoo! That's probably going to be it for today. Let's just kind of step back and take stock of where we are. This test harness is going to be fun, but a big chunk of work. Probably be more than one stream. API docs. Yeah, I'm not looking forward to that. I like writing docs, but writing docs on stream, I'm not sure how that's going to go. Could be interesting. Maybe it'll encourage me to write really good docs. I'm pretty good at writing docs. For the initial PR, I'm not going to force myself to write great docs. Build system thing. That's going to be interesting. I haven't decided how to do that. We have 2 build systems involved. And ideally, you just build, you like cd into the Rust crate directory and run cargo build, and you get the, actually, I mean, you don't run cargo build in the Rust crate directory. You import that crate. And then the build just has to work running cargo. So really, the cargo build has to drive the Zig build in some way. And there's going to be several different configurations. Like for a crate published to crates.io, it's probably just going to bundle the TB client library as a static library just directly in the crate. But when you're building from the source directory, it'll probably probably what we'll do is have the cargo build script kind of reach out to the outer Zig Tiger Beetle build system and manipulate the Tiger Beetle build to make those libraries show up in the right place before doing the Rust build. Kind of might want to look at how the other language bindings are using the Tiger Beetle build system. Go bindings. You want to look at the Go bindings once and run Foreman and Clippy. All right, we're so close. Basically, these are the 3 big tasks. Create a test, write some docs, do the build system. Okay, y'all. We're going to wrap it up. My name is Brian, Burson on GitHub, BRSON. My socials are on my GitHub pages, which is burson.github.io. I'm doing this project, this Rust client bindings for Tiger Beetle, all on stream. I don't have a regular schedule, but I usually announce it 10 minutes beforehand on the Tiger Beetle Slack and on my Mastodon account. I'm expecting this project to continue for a while. Maybe in a week or 2, we'll be able to submit a PR for the initial round of review, and then there's going to be a lot of production work after that. So I really appreciate everybody showing up in chat and, helping me out. I need a lot of help on stream. I don't know everything. I know so little. I'll be back again in a few days, maybe tomorrow, maybe the next day. I don't know, but I hope to see you all again. Thank you so much. Good night.